Use an element argument to prove each statement in 7 through 22. Assume that all sets are subsets of a universal set U. For all sets A, B, and C, if A is a subset of B, then A union C is a subset of B union C. Now we're proving an if-then statement. The way we traditionally prove an if-then statement directly is we start by assuming the if part and somehow concluding the then part. So we're going to assume A and B and C are all sets. We're going to assume that A is a subset of B. This is a key assumption here. And we need to prove that A union C is a subset of B union C. Now, whenever we need to prove anything as a subset of something else, we need to start by instantiating an arbitrary element in this first set. So we'll say let X be an element of A union C. The goal to prove this whole statement to be true, the ultimate goal is to show that X is an element of B union C. And we can use any of these assumptions here, that A and B and C are sets, A is a subset of B, and X is an element of A union C. The first thing I think we should unpack is the definition of union. We can say what it means for X to be an element of A union C. So by definition of union, X is an element of A, or X is an element of C. Now, we've led to a conclusion that uses the or statement. Now, we've come to a conclusion that uses the or operation, which usually in a proof, if we come to this point, we'll need multiple cases. The case where X is an element of A, and another case where X is an element of C. So case 1 is going to be X is an element of A. We want to show that X is an element of B union C. Now, since A is a subset of B and X is an element of A, then by definition of subset, X is an element of B. Since everything in A is also in B, then that must also be true for X, which is an element of A. That means X must be an element of B. Now, we want to show that X is an element of B union C, but that just means that X is in B or X is in C. But we already know here that X is an element of B. Now, to get that X is an element of B union C, we have to use addition, which is a rule in propositional logic that allows us to add statements using the or operation. So because we already know X is an element of B, then we can say X is an element of B, or, and then we can put anything we want here. It doesn't really matter because we already know that the first part is true, and in order for an or statement to be true, at least one of these statements has to be true, and we already know the first one is true. So the second statement here could literally be anything, and that's why they call it addition, is because you can add on literally anything here. But now we have that X is an element of B or X is an element of C. So by definition of union, X is an element of B union C. And that's the goal. That's what we wanted to show. We wanted to show that X is therefore an element of B union C. But this was case 1. There's also another case, because keep in mind we had to split this up with this or operation here into case 1, X is an element of A, or case 2, X is an element of C. So let's go to case 2, X is an element of C. Now, since X is an element of C, we can use addition again, which means that X is an element of B or X is an element of C. And we know this because X is an element of C. And so because we have this or operation here, by definition of union, that means X is an element of B union C. And notice that in both cases, we prove that X is an element of B union C, which means that no matter what, X is an element of B union C. So we started with an arbitrary element from A union C, and we showed that no matter what, X also has to be an element of B union C. X must therefore be an element of B union C. And that's the proof. Thanks, everyone, and I'll see you in the next video.